Okay, this is the 4.1 to 4.13 quiz. I skipped these questions since I've already solved them in previous recordings. I'm doing the new questions that we haven't seen before. These couple questions, I think these questions are pretty hard. Not hard, but they're just a bit longer. I think they're one of them might come written صراحة. مهم, stop yapping. Seesaw of length 100 centimeters has two masses, 40 and 60. Where is the center of gravity located? Okay, think of it like this. Seesaw here, 400 newtons, 600 newtons. Okay, why 400, 600? Because I told you always convert it to newtons by multiplying by g, which is 10. It's already in kilograms. المهم, this force is here, this force is here. We want to know where the center of gravity is. Okay, طيب. Always. What's the steps for solving these questions? Please don't use the formula W1 over W2 equals G2 over GG1. That's when you have two systems. Here we're only talking about the seesaw. So you just have to do this. We're working with moments. ف what you have to do here, like any other question where we're asked to find where do you put it to balance or whatever, where do you place the fulcrum or whatever. The first step is to identify all the forces. We have this force, let's call it A, let's call this force B. What's going to be the reaction to this force? 1000 newtons. Always identify your three forces, okay? These are steps to solve. Damon. Okay, then pick your point of rotation, okay? Either pick A, pick B. Where I'm going to pick A, okay? Uh, Now we have to understand sigma m equals 0. Why sigma m equals 0? Because شو اسمه uh, where is it sigma m equals 0 because we're balancing the seesaw. Okay, we want, if at the center of gravity we're balancing out the seesaw, right? فsigma m equals 0. Always solve like this. So يعني 400 uh sorry, whoa, what am I saying now? We have three moments here. We have the moment of A on A, which is 0, obviously, so we cancel it out. The moment of the normal reaction on A, which is 1000 times, let's call this L, the length. Okay, and then the moment of B around A, which is 600 minus 600 times 1. Okay, why minus 600? What's L? Whatever. 1000 L, we don't know the length between A and 1000. Uh, Minus 600 because it's going clockwise. This stayed 1000 because it's going counterclockwise, yeah? Uh, Minus 600 times 1. This is a 100 centimeter seesaw. So if you want to take the distance, put 100, you'll get it wrong. Why? Because you need to put it in meters first. It's going to be times 1. Sigma m equals 0. So 1000 L plus minus 600 equals 0. Take minus 600 to the other side. L equals 600 over 1000. L equals 0.6 meters. They want it in centimeters. Okay, so it will be 60 centimeters away from the 40 kilogram person. Always the distance you get here is from the point of rotation. So if they're saying from the 40 kg person, so yani take the 40 kg person as your point of rotation. Okay, always that's how you choose. If they don't specify, then انت بتألف من عند حالك. Okay, you make something up. What's the force exerted by the fulcrum? Obviously 1000, and you needed it to solve part A also. But some people solve using a different way for part A. They just do no, you can't use that way here. If they give you the distance between one of them and the center of gravity, then you can solve using the other way, which I'm pretty sure many of you know. Like مثلا if they give you the center of here and you have 40 newtons and this is 0.2 meters, and then they give you 60 newtons and they tell you find x. Some of you would do 40 times 0.2 equals 60x, but in this case you don't have any distances given, okay? You only have the total length, so you have to use this way. Some people use a different way also, where they actually take this 1000 as the center of rotation, and they do L, and this distance is 1 minus L, and they find the moment of each one. I don't like this way. It's a bit longer, and it needs a bit more understanding. I like my way more. You only need 1 L. يعني there's no distributions. ما في شيء. Question 10, yeah. This also we did AB because you hang it, it's gonna turn, it comes AP. Oh, كمان the weight, the moment of the weight is gonna be 0 because انت once you hang it, it's gonna be tilted like this, yeah. Uh, Hold up. Yeah, it's gonna be tilted. Oh, wait. Yeah, it's gonna be like this. A is here, B is here, B, it's vertical, right? This is AB, and if you're hanging it from A, then okay, there's gonna be zero moment since it's coinciding with A. I don't think this came actually the last AMS. حطوها بالquiz I don't think they got it. Okay, unstable shape. For an object to be stable حطوها عندك انه memorize this. For an object to be stable, the center of gravity must be يعني the center of gravity should be coinciding with the floor or the surface you're using. So have a look here. If this is X is the center of mass, does it coincide with the floor? Yes. So and obviously this one won't fall. Does this coincide with the floor? Yes. Does this coincide with the floor? Yes. If it stays, it won't fall. Does this coincide with the floor? No. If it's wrong. So it will fall. So it's unstable. Question 13. Okay, this is easy. The moment of any couple is FD. I think I've solved this before. So 15 times 0.02 because you need to convert it to meters and you get 0.3. Question 14. Okay, I solved a question like this in the course revision, but I actually solved the same exact question in the course revision. Is it the same? Question five. It's the same thing. It's the same question. Yeah, 5, 10. Yeah, it's the same question, but they changed the mass from 5 to 7 and from 10 to 14. But you're still gonna get the same. المهم, let's do it. Here, they want the center of gravity, but you have two systems, right? Two systems. This sphere and this rod. The sphere has a mass of 7 grams and radius 1. So over here it's 1. And it's attached to point A, which is mass 14 and length 8. So where is the center of gravity of the pen? If you are finding the center of gravity of of two systems, W1 over W2 equals GG2 over GG1. Please watch the course revision video. It's very important. Okay, W1, W2, whatever. I like putting the heavier one up. Okay, put the heavier one up. That's what I like. So let's look at the heavier one, which is heavier, 7 grams or 14 grams. Uh, weight is W equals mg, right? So you can't just put 14 grams, 7 grams. You're not allowed. So it has to be, it will become 0.014 times 10 because mass in kilograms of 14 grams is 0.014 and g is 10. You get 0.14. Then the weight 2 is 0.007 times 10, which is 0.07. Okay, so let's solve this a bit. 0.14 over 0.07 equals GG2 over GG1. Usually when solving, once you divide these two, you're gonna get a constant. Okay, so if you divide 0.14 0.07, you actually get 2. So 2 equals GG2 over GG1 because this 0.14 is double of 0.07. So what do you get this? Once you cross multiply, you get 2GG1 equals GG2. Okay, طيب. Let's see here. Here's for it cuts. Here's the center, right, at 4 centimeters, because it's a uniform rod. It's a uniform rod. For the center of gravity is always in the midpoint and halfway. If you didn't watch my course division video, you're gonna be lost. Trust me. Please watch it. For the center of gravity, it's always halfway for a uniform rod. Okay, so when you're saying GG2 and GG1, it's the distance between. G is the center of gravity for the whole system. G2 is the center of gravity in this case for the rod, which is over here. This is where G2 is. Okay, and G1 is the center of gravity for the other object, which in this case is the sphere, which is over here. You know, the center of gravity of any sphere is in the center of the sphere. It's like, where's the center of the circle? Over here. Okay, so you know that G1, GG1, sorry, plus GG2 equals 5. Why? Because here, G is somewhere here. Let's say it's here. Okay, G1, GG1 is this, and then GG2 is this over here. This and this, right? These two segments. If you add them up, you're gonna get 5, right? Because this whole thing is 5 centimeters. You have 1 centimeter here, and you have 4 centimeters here. Okay, so GG1 plus GG2 is 5. Do we know what GG2 is? Yes, we do. It's actually 2GG1. So GG1 plus 2GG1 equals 5. You get GG1 is equal to 5 over 3, which is 1.67. Okay, 1.67 centimeters. From where? Okay, from where? We're saying 1.67 centimeters. Uh, sorry, what am I saying? GG1 is 1.67 centimeters. That's what we found. So this here, let's say here's G. Uh, and this is over here G1. Here's G1, here's G. That means this is 1.67 centimeters. And you know G2 is over here. Okay. Where is the center of gravity located? Uh, from point B. Yeah, I did something wrong. Um, this is weight 1 over here. This is weight 2, right? So that means G2 is actually the center of gravity for uh, the rod, for the sphere, قصدي. So this is G2 and this is G1. This is G2 and this is G1. Yeah, yeah. So I did it wrong. I just drew it wrong. For GG1 is 1.67. That means this distance here is 1.67. Okay. So how far is it from B? You know, this is 4 centimeters because it's halfway, right? Here's 4 centimeters. Half of 8 is 4. So 1.67, 4 centimeters, you get 5.67. Okay, so I just drew the graph wrong, but everything else is correct. Please, if you don't understand this, I rushed it a bit. Watch the course revision uh, uh, quiz. I explained it very well. Um, إيش course revision? Course revision recording. And like I said in that recording, to solve these center of gravity questions, you need two equations. You need the product equation, okay, the product equation, and you need the sum equation, okay. The product equation you find by applying W1 over W2 equals GG2 over GG1, and then the sum equation you find it by just adding the distances, okay, adding the distances. In this case, our product equation was 2 GG1 equals GG2, and we found it by how? Because we said 2 equals GG1 over GG2. If as the GG2 over GG1, ya Allah, it's GG2 over GG1, because we got this over here. And then the sum equation is when we said uh, GG1 plus GG2 equals 5. Once you're able to find both of these equations, then you can solve the whole thing, okay? Question 15, please, by the way, I explained it. I can show you like videos, physics 4 point, where is it? Here, I think. Yeah, over here. What? This may defies unsupported. Huh? Huh? Yeah, yeah, I don't know why the file got corrupted. I'll save it again. But over here, I solved it. Wait, here. Yeah, like, oh, I don't think you can hear the audio. Yeah, find the center graph. Yeah, over here, over here. Uh, watch it, trust me. I explained it in a way better way, and I was slow. Here I went a bit fast. Okay, wrap it up. Let me continue. Question 15. I solved this in an AMS, but let's do it. The magnitude of x. Okay, if you want to solve this fast, 50 times 0.25, right? That's the moment here, equals 0.4x. 0.4 times x. Walid, why are you going to divide by 100? Because centimeters to meters divide by 100. Okay, whoa, that's not a good handwriting. المهم, you get x equals this divided by this. So 50 times 0.25 over 0.4, you get 31.25, which is rounded to 31. Okay, the upward force exerted by the fulcrum. Okay, what is the upward force? If you have 31 here and you actually have the weight, which is 20, because they said it has a weight of 20. What's the upward force going to be? You just add them up: 50, 20, 31, 101. Question 16. Okay, this is where stuff gets a bit hard. Forget about this. They said they're investigating the law of moments, so they put a uniform stick and they started playing with the distances. Okay, so they started to they kept the weights balanced, and they started moving. They played with the distances, and they wanted to see, what effect is that gonna have. They drew the distances. So we have distance A, distance B. Okay, the first thing they say is the slope of the graph. How do you find the slope of the graph? Y2 minus y1 over x2 minus x1, and everybody knows this. So in this case, let's take these 2 points. Let's take these 2 points. which is y2 is 0.3 minus this point over here, let's say 0.15 over 0.2 minus 0.1, you're gonna get 1.5. Part A is easy. Grade 7s, grade 6s can solve this. Part B, this is the part, it's a bit tricky. Okay, the unknown weight. So if you had here was if you had here was 30 centimeters and here's 20 centimeters, everybody could be able to solve. They say W times 0.2 equals 2 times 0.3. Easy. But here's the thing. You actually have A and B given, but you need to like figure it out in a way. If you look at our graph here, they won't just ask you to find the slope, yeah, just because they want you to find the slope, and just like this. They want you to find the slope because obviously you're going to use that slope over here. Why? Okay, if you realize B over A is equal to 1.5. What are you saying? Look, 0.3 divided by 0.2 is 1.5. وأصلا in any line that passes through the origin, the y over x is always equal to the slope. Okay, يعني I thought I'd let you guys know. But b over a in this case is 1.5. This is the way I solved it. Maybe you guys have a different way, but this is the way I found. So if b over a is 1.5, can we can we make our solving in a way where we can get b over a? Let's see. Type, we know w times a equals 2 times b, right? So let's write that down. W times a equals 2 times b. Can I put b over a? Let's start by moving this 2 over here. If you're multiplying by 2 over here, that means you're going to divide by 2. So let's divide by 2 on both sides, right? So it will be w times a over 2 equals b. Equals b. Okay. Can we take this a here? Of course we can. So you divide by a on both sides. So it becomes w over 2 equals b over a. Okay. What did we... Now we have b over a. What did we say b over a was? 1.5. For w over 2 equals 1.5. For the weight is 3 newtons. There you go. Question 17. I think this is the hard one. No, this one's easy. By the law of moments, okay, so they put a fulcrum here of a stick and then they hung a weight. Okay, the fulcrum is 70 centimeters away and the weight is over here. So by the fulcrum, by the law of moments, for the meter stick to remain at equilibrium and it doesn't move, the torque of W about the fulcrum must be equal to the torque of the meter stick's weight. Why? So look, you have this force over here that has a moment, this W, right? So what other weight is going to cancel out this W? Actually, it's going to be the weight of this stick, right? Of the stick. So the only thing that can cancel out the weight of the object here is going to be the meter stick's weight. طيب, if the meter stick is uniform, then its mass is how much? Okay. أول شيء, one thing I want you to realize that there's no force over here. There's no like other force. So if you were to use, they gave you a list, by the way, of values of W that you can use, along with some values of D that you can use. Some people might do 4 times 0.275 equals 0.7 times the force. I actually didn't try. You should get it wrong if you do this. I didn't try this because I knew it was wrong. But let me see. 4 times 0.275 divided by 0.7. Yeah, you get a different wrong. You get a different answer. So what I need you to pay attention to here, they're asking for its mass, and you know the mass. Well, you need the weight to find the mass. This stick is uniform, and it's 100 centimeters long. So where will the weight be placed? I told you the weight on any uniform stick is going to be halfway through the stick, on the midpoint of the stick. So it's going to be over here, and I'll call it capital W. Weight. So let's see here. The weight is actually 50 centimeters, and then 50 centimeters. So let me clean this up a bit so I can show you what I'm trying to say. This weight is going to be over here, which is halfway. So it's 50 centimeters here, and the same on the other side. I won't draw it because I want to show you something. The fulcrum over here is already there, right? So this thing, is distance here is 50 centimeters. So they gave you the point of rotation is over here. Type. Can we figure out uh, the point of rotation? Yes, we can. No. Can we figure out how far the weight is from the point of rotation? Of course you can. If this whole thing is 70, this whole thing is 70, and this is 50 down here, that means this distance here is obviously going to be 20, right? Type. For the W and D, you have the values given. ف since it's gonna be since it's gonna be a balanced stick, sigma m is gonna be 0. You can use this for all the questions. Also, you're supposed to use sigma m equals 0, but you guys, you do W times 0.2 equals, let's say, 5 times 0.22. You just multiply. But if you do this in the written, I'm pretty sure you're gonna get deducted marks because you have to show why. And why using this? Because sigma m equals 0. Okay, sigma m equals 0 معناتها if you add this moment for the weight to the fulcrum, it's gonna be equal to the moment of this W to the fulcrum. What's the moment of the weight? Capital W. I put weight because I don't know why they're putting W for you as the force. The moment of the weight is gonna be the force minus W, because it's clockwise, minus W because it's clockwise, it's gonna go like this. Minus W times the distance, which is 0.2 because d perpendicular. Sorry, because the distance is in meters, you convert to the distance is in centimeters, you're converting to meters. 20 divided by 100, 0.2. Okay, then the moment of this W here. Okay, you can choose any 3 points or any whatever, any column you want. Let's take the first one. Why not? So the moment of this small W, I don't know why they're giving you W again. It's gonna be 4 positive because they're gonna go counterclockwise. Okay, times the D, which is 0.275, converted to meter, 100, whatever. So 4 times 0.275, which is 4 times 0.275, 1.1, 1.1 minus 0.2 W equals 0. You get 0.2 W equals 1.1. So W equals 1.1 divided by 0.2. You get 5.5. W equals 5.5 newtons. Walid, what is the answer in grams? Oh, what is the answer? 550 grams. Type. Can you convert? We used to convert mass to newtons. Now you should be able to convert newtons into grams. So let's see here. So W equals mg. If the weight you know is 5.5 and you know g is obviously 10, you should be able to, you should find the mass. You do mass is 5.5 divided by 10. Mass is 0.55. Convert this to this is in kilograms. Always the mass you get is in kilograms. Convert this to grams. You do times 1,000, 550 grams. Okay, 550 grams. Question 18. Is this the last? No, I think there's a 19 also. This one's kind of hard. Okay, but it's very easy at the same time. You have a length of a rod, length 100, and its weight is 30. So the weight is down here at 30. It's a uniform rod, so the weight is gonna be over here at 50. Okay, it's kept at an angle of 37. Okay, by a string over here. Okay, by taking the moment about point A. What is the tension in the string? Okay, since it's balanced, sigma m equals 0. That means the moment of this weight plus the moment of, because this rope is hanging it upwards, right? Plus the moment of this rope equals 0. Think about it like this. What's the moment of this force over here? This force. This moment. The moment of this force. Let's call it the weight force, which is 30 newtons. Can you find it if A is your point of rotation? Yes, you can. Let's see. The moment of W around A. It's going to be minus 30 first because it's clockwise times d perpendicular. The perpendicular. For the people who put 0.5, you're gonna get it wrong. It's not how you do it. The perpendicular. This is the distance. Is this perpendicular? Obviously not. For what do you do? What do you do? You have to see, you connect it. This is your D perpendicular over here, right? This is your D perpendicular down here. It makes perpendicular here. So you need this distance. Can you find it? I'm sure all of you are familiar in math. If you have 37 here, you have a distance here that's called x, and you have the hypotenuse is 50. Can you find x? Of course you can. Cosine 37 is the adjacent over the hypotenuse. X is adjacent to 37, 50 is the hypotenuse. Adjacent over hypotenuse gets you cosine. So can you find this adjacent side x? X is going to be equal to the hypotenuse times cosine 37, because you cross, huh? So x is going to be the hypotenuse 0.5 meters times cosine 37. And what do you get? 0.5 cosine 37. You get whatever that is, yeah. Let's just put it as 0.5 cosine 37 because that's a bit of a small number. Okay. After doing this, you get an answer. The answer should be negative 11.97. Okay, negative 11.9795. It's a long number, so I'll just put it like this. Okay, but on your calculator, keep it as answer. So this is your moment of W around A. How about the rope? The moment of the tension around A. It's equal to the force of the tension. Do we know what it is? No, we're trying to find it, right? The force of the tension times the perpendicular. How do we find the perpendicular? Same exact concept. This is the force here, right? Right? But the distance here that connects it is 100 centimeters. But we need, let's extend the force. Where's your perpendicular? We need this distance over here. We need this. Same thing. Triangle, you have 37 here. This side is adjacent. This side is the hypotenuse up. So again, cosine 37 equals x over 100 centimeter. Let's keep it as 1. Cosine as 1 meter. So what is x is going to be equal to 1 cosine 37, which is just cosine 37. Okay, so the perpendicular is actually cosine 37. So the moment of t around A is going to be the force of t times cosine 37. Okay, so can we add these? Yes, we can. Cosine 37, ft times cosine 37, because that's the moment here, minus 11.98 equals 0. 11.98 to the other side. You get the force of t equals 11.98 divided by cosine 37, because you're taking also cosine 37 to the other side. You should get, oh, I'll put the wrong number. You should get a number that's very close to 15. 15.0000 something. Okay, so just take 15 as your answer. Then what's the magnitude of the normal reaction going to be? The magnitude of the normal reaction is going to be equal, so obviously if this is 15, this is also going to be 15, because the magnitude of the normal reaction, whatever. The tension in the string, the normal react. Oh, wait. Yeah, the normal reaction in this case, sorry. It's equal. So look. You guys know that the normal. Let me erase all of this. The normal reaction is going to be this force. This is the normal reaction. In this case, the normal reaction is actually equal to the force that the tension rope is putting up, because that technically this is the normal reaction. It's the one canceling out this weight. So if we found this is 15, so the normal reaction is 15. Okay. The last question, 19. Uh, a non-uniform plank of length 400 centimeters is held by two vertical cables. The tension in the left cable is 500 newtons. Tension in the right cable is 300 newtons. UG equals 10 meters per second squared. Okay, so this rope is pulling at 500 newtons. This rope is pulling at 300 newtons. What's the mass of the plank? Okay, wait, is it like this? It's the other way around, not downwards. I think it's upwards. Here it's 300 newtons. has a 5, left is 500 newtons. The right is 300 newtons. Uh, yeah, what's the mass of the plank? For these ropes are putting in this force to cancel out the weight, right? It is 500, this is 300. Okay, the weight is 800 newtons. But they want the mass, not the weight. For W equals mg, so 800 equals the mass times 10. You get the mass is 80 kg. The center of mass of the plank is located something meters away from the left cable. Okay, now we know that the weight is here. Okay, it's here, it's 800 newtons. But one thing to pay attention, they said non-uniform. Okay, so you can't say that the weight is halfway between since it's non-uniform. Okay, here we said it's 500 newtons, and here we said it's 300 newtons. So the steps to solving these questions I always told you is أول شيء identify your forces. We have them identified here, the left cable, the right cable, and the weight. And then step 2 is to pick your point of moments. And they said from the left cable, let's take the left cable as our point of moments. So since it's being balanced, it's held horizontally, it's balanced, sigma m equals 0. Always write sigma m equals 0 since it's balanced. Okay, in your written, please always write sigma m equals 0. What does this mean? That means the moment of, let's call this A, let's call this the weight, and let's call this B. The moment of A around A is obviously 0. The moment of the weight around A is going to be minus 800 times D, right? Because we don't know this distance. And then the moment of B around A is actually 300 positive because it's up, it's counterclockwise, times 4. Why 4? This length all is 400 centimeters. So this length is 400 centimeters. So, well, 400 centimeters to 2 meters is 4 meters. 300 times 4. So let's add these up. This is 0. So we take it out. 300 times 4 is 1200 minus 800d equals 0. You take 800d to the other side. D is going to be equal to 1200 over 800. Boom, cancel, cancel. 12 over 8 is 1.5. Sorry, 0. No, yeah, 1.5 meters. Convert this to centimeters. It's times 100. It equals 150 centimeters. Thank you so much for watching. Good luck. I'll post 5 now in a bit.